This vehicle was brought into us with a symptom of excessive oil consumption. Other symptoms of this vehicle: hesitation on acceleration, rough idle, different things. The major issue is the oil consumption. The owner was complaining of oil consumption, having to add a quart a day, basically, on a commute. So what we did was we drove this vehicle approximately 30 miles. We topped off the vehicle before it was taken on this drive. 30 miles later, here we are. We're going to check the oil level now. You can see the oil level is right now at the add mark, possibly even below the add mark. So what we're looking at in about a 30-mile test drive, this vehicle's consumed approximately a quart of oil. We can verify the customer's complaint. First step, vehicle is consuming an excessive amount of oil. So another thing that we're going to do, we're going to inspect each tailpipe. This is a true dual exhaust system on this vehicle. So there's no commingling of exhaust gases from the right bank to the left bank, or bank 1 or bank 2. So with our symptoms that we have of excessive oil consumption and misfires on bank 2, what we're going to do is look in the tailpipe to see if we can determine if there's any oily deposits on one bank or the other. Okay? So first we're going to start with bank 1. I'm going to take a finger, run in to the tailpipe. Wet from the water and a little bit of carbon. So we're going to compare that to bank 2. Greasy, carbon-laden, oily deposits. So it's very dramatic how much oil is in here. It's just very slick and slippery. We know that there's been a lot of oil come through this tailpipe, and over here, nothing. So that's another tip or trick that you can use to help diagnose a symptom such as this, or a cause. So we'll continue on. Okay, right now what we're going to do on this Chevrolet truck, we're going to do a power balance test. You can see the RPM looks like it's continuing to creep up a little bit, indicating what we suspect to be an intake manifold gasket vacuum leak. So the extra air that the engine is receiving is allowing it to creep up an engine RPM as being less governed. So what we're going to do is sort out individual cylinders one at a time. The machine will indicate how many engine RPM have been dropped by removing that cylinder from the engine's firing order. We'll start with number 1. So we're dropping between 100 and 120-ish RPM. The vacuum reading has dropped by a couple inches. Release the button, it re-engages the cylinder. Now we're back to 900, 920 RPM. We'll continue with the remaining cylinders. Were a little low. We'll redo those cylinders. Notice the vacuum gauge didn't drop much. Tools indicate it's dropping only about 30 RPM. That means the cylinder is being affected. It's not a dead miss. It is a weak, partially non-contributing cylinder. play. The weak's only dropping 30 RPM, ballpark. Again, not a dead miss, not a great cylinder either. RPM approximately 920, 930. Hasn't changed a whole lot since the beginning of the test. We have indicated some weakness in 2 cylinders, number 4, number 6. So we're going to continue to work on this vehicle and see if we can discover the root cause of those 6 cylinders. Okay, one of the things that we can do on a vehicle such as this one that has a true dual exhaust system is we can look at the exhaust pipes, we can listen to them. We can do a variation of the old dollar bill trick to see which bank may have a misfire concern. Bank 1 has, after we've already done the power balance test, we've determined that no cylinders on bank 1 were misfiring. So what you can do is take a piece of paper, a piece of plastic. This is a sanding disc. Hopefully this will come through on the video. It should be a more rhythmic pattern on the left bank, and on the right bank we have 2 cylinders that are weak. So we should be able to see an irregularity. Bank 2 has an irregular note, an irregular amount of an exhaust pulses coming out of the tailpipe. So we can determine just from that there is an issue on bank 2. Okay, now what we're going to do is we're going to pull a spark plug. The vehicle has long tube headers on it. 4 and 6 rather are the cylinders that were indicating low, weak on the power balance test. 6 is a little bit harder to get to, so I kind of cheated. I'm just going to pull the easy one here. I loosened it up already. We'll pull it out and we'll see what spark plug number 4 looks like. Oily, burnt, carboned up ash deposits on this spark plug. Obviously these plugs are going to need to be replaced. However, the spark plug is not the root cause of the problem. The spark plug is damage caused from the root cause. So this is basically another test that we've run, a visual inspection of the spark plugs. All of the tests that we've done, all of the issues that we found, we're going to use those and hopefully come to a conclusion of the root cause of this vehicle's mechanical problem. Now we're going to check the engine vacuum in the crankcase. We suspect that this vehicle may have an intake manifold gasket leaking, so what we're going to do is we're going to remove the PCV vacuum from the crankcase. We've already plugged the fresh air inlet of the crankcase, so we're going to measure to quantify the vacuum which is present in the crankcase. Normally a vehicle that does not have a PCV hooked up should have a little bit of positive pressure from the blow-by in the crankcase. So we're going to see what we have right now. We're showing approximately 10.5 inches of vacuum. That's not right. We know that we should have a little bit of positive pressure coming through the piston ring. Again, the PCV is not hooked to the crankcase. This vacuum is being developed somewhere internally in the crankcase. We suspect it's intake manifold or intake manifold gasket failure causing this concern. But if you have a suspicion of an intake manifold gasket leaking into the valley, this test should be able to confirm that as a possible root cause of this problem. Alright, we've started to pull this intake manifold off, and just before the manifold's getting pulled, went to inspect the gasket, and we can see that on bank 1, above the runner for number 4, it looks like, that this gasket is proud of the manifold here. It looks like it's been pushed out. And if we look back a little bit further here, cylinder number 6 has an identical amount of gasket protrusion. So, right before the manifold comes off, we know that we can see some problems here. If we look at the opposite bank, the valve cover hasn't yet to be removed, but in this area is the gasket. I don't know if you can see that very well, but it comes right up in here, and it's substantially further down into the manifold sealing surface. And as well, I'm sure you can't see that, but yeah, right in the middle of the screen is the gasket for the back 2 cylinders on bank 1. So again, rear 2 cylinders for bank 2, front 2 cylinders for bank 2, front 2 cylinders on bank 1, and the rear 2 cylinders on bank 1. Okay, we're going to continue to pull the manifold. Okay, we have removed the intake manifold, and as expected, we found that the gasket on bank 2 has failed. We zoom in a little bit, we can see cylinder number 4 at the bottom of the gasket has broken. It appears, if you look a step back a little bit and look at the gasket, it appears that the gasket has layers, and those layers separated in the middle, and the upper half of the gasket has slid up. If you look at the top of the port of cylinder number 4, the intake port, you can see how proud that gasket is of the port. It's pushed up. We don't know why that happened. We don't know if it's a defective gasket or if there's warpage, but we're going to continue to look for it because we always want to see if we can determine why something happened. But if we look at the top of the port of cylinder number 6, something just like that happened. That makes sense from what we saw with the power balance test. Number 6 and number 4 were low on the test. And again, on the bottom of the gasket, it's separated. There's a definite break in the gasket right there in the middle of the screen, so we can see none of the other ports on this bank look to be broken, but I'm sure given enough time they would. It appears that this separation, let me see, back up a little bit. This separation or sliding of the gasket, is going to affect these 2 middle cylinders the most, just from the way that the failure occurs. So that's kind of a unique thing, and I'm wondering if anybody else with Edelbrock gaskets or manifolds have had issues like this. This is a Vortec head on an older style block. I don't know if that matters a whole lot, but I'm going to walk around and show you the other bank. You can see how normal it looks. Okay, so on bank 1, the separation does not look like it has occurred at all. There's no break here in the gasket on either of the 2 middle cylinders. These 2 holes in the gasket look to be lined up on this bank, and if we slide over to the other bank, we can see that these holes have been slit apart. So this is a kind of a unique failure. It's kind of neat to see this type of failure. Except paying for the repair exactly, but that's what we've seen, and we're going to do some more diagnosis and see if we can determine why this gasket failed. So we've got the cylinder head gasket surface cleaned off right now, the intake gasket sealing surface. Cleaned off, scraped off, and next thing we did was wanted to measure the warpage of the sealing flange. So you got a flat edge and feeler gauges, and went after bank 2 and found that there's less than 1,000th variation in that flange. So that's not the root cause. So we'll continue to look. Here's the part number of the Felpro gasket set that we're going to use to replace the Edelbrock gasket set. Part number MS98000T. Gasket set, sent the customer back $65 and included some additional gaskets that we're not going to use. This gasket is a steel backer with rubber. It's a reusable O-ring around the bolt holes. It has metal flange, so it can't be crushed. This gasket feels like it weighs, it's a substantial gasket. So I think unless we find any other root causes, that we're going to probably have a pretty successful repair. Okay, we've cleaned off the intake manifold gasket sealing surface. Checked the warpage with the straight edge, feeler gauges. There wasn't really any issues that I found. Right on the very ends of this manifold, it's raised up just a little bit, and that caused there to be 1 or 2,000th warpage, between diagonally across. Measuring it straight across, really didn't see any warpage at all. However, right here in this area of where the coolant passages in the cylinder head, it's deadheaded right here up against the manifold, I did see, straight across this area there was about 2,000ths. However, it was not leaking in that area. I believe that the Felpro gasket that we have is going to be okay to seal that up. I don't foresee any issues with that. So that's what we're going to do. We're going to see if this will seal up. I don't really see any reason not to go back together with it right now. Okay, we just installed the intake manifold assembly. Everything fit fine. We used a bead of RTV on the end rail. Cleaned off the bolts. Some of the bolts protrude into the vacuum ports, so all of the intake manifold bolts were sealed with black RTV before we threaded them in. We tightened the bolts in 3 stages. First stage, 50 inch-pounds. We tightened them in a crisscross pattern to evenly pull the manifold down. Second step, I believe 80 inch-pounds, and the third step was 132 inch-pounds, which is 11 foot-pounds. So 132 inch-pounds, which was 11 foot-pounds. So everything went well there. We're going to continue to put it together. Okay, so the repair has been completed. We went ahead and installed the intake manifold assembly, torqued all the bolts to spec, which was 11 foot-pounds. Of course, before that, we double-checked the warpage on the cylinder head and on the intake manifold, both sealing surfaces, and we really didn't have any warpage to speak of. So the new Felpro gasket, the metal base gasket with rubber O-rings on each side, basically that style of design was installed. Again, torque to spec at 11 foot-pounds. Oil was changed. The distributor was installed and timed. Basically, we completed the repair at that point, added the proper amount of coolant, and started the vehicle. Did some timing adjustments. And now what we're going to do is we're going to retest the power balance. We're going to see if the 2 cylinders that we had previously misfiring, number 4 and number 6, are now are now back. So what we'll go ahead and do is start the vehicle and we'll perform that test. Okay, we're going to continue. We're going to do a power balance test on the engine. It's approaching. It's not reached full operating temperature at this point. The idle's smoothed out. We're off at the fast idle cam. So again, if you remember the previous test, we're going to do that same test exactly like we have before. We're going to see how many of these cylinders are weak, misfiring, or non-contributing. To 60 RPM drop, and back. $20, $30, $40, and back. $30, $40, back. Before was the cylinder that we previously had a misfire on. You can see now it appears to be contributing help to the engine. Looks like we're dropping approximately 30 to 40 RPM. Looks like this machine has detent, so to speak, of about 10 RPM. Can't differentiate between 10 RPM. So bouncing back and forth probably means we got somewhere around 35 RPM to drop. I'm going to go back to number 2 and look as though number 2 might have been a little weak. 30, 40. Looks good. So doing this test again, we can see that the previous symptom of a misfiring cylinders number 4 and number 6 has been corrected. Looks like all cylinders have a pretty even contribution to the health RPM of the engine. We'll continue on and we'll check some other things as well. But right now, it looks like we've had a pretty successful repair. Previously, one of the tests that we performed on this engine to diagnose the problem was to measure the vacuum present in the crankcase. At that time we had, I believe it was over 10 inches of vacuum in the crankcase, even with the PCB not hooked up. So we knew that that was wrong. Now what we're going to do is we're going to again look at the same test, vacuum gauge. Can we zoom in on that? Actually, we can see that there's no vacuum present. If I pull off the plug that I have in the fresh air, I've seen that it's actually pushing a little bit of gas out, a little blow-by gas. That's normal. So the symptom that we had, vacuum bleeding into the crankcase, right now, we've eliminated that problem. That's a good sign. Previously, one of the tests that we did to determine if this engine had a misfire, being that the truck has true dual exhaust, we listened to the exhaust note coming out of each tailpipe to determine that bank 1 had a consistent note. It sounded very repeatable. As opposed to bank 2, whose exhaust note was erratic. The pulses coming out of the tailpipe were very even on bank 1 and erratic on bank 2. So now that we've gotten our misfire corrected, I'm going to show you again the pulses, and hopefully you'll hear it when I put this piece of plastic up against the tailpipe. If your vehicle has true dual exhaust, this is a test you can do to determine, at least bank to bank, if there's a discrepancy, possibly a misfire or some other mechanical problem. Bank 1. even, it's a very rhythmic pulse, smooth running engine, no misfires here. Good job.